Bismillah ar-Rahman ar-Rahim. Random variable x has the PMF. Px of x is equal to 1 over 4 when x is equal to 0, 1 over 2 when x is equal to 1, 1 over 4 when x is equal to 2, and 0 otherwise. For the random variable x, find part A expected value, part B variance, part C standard deviation. So first of all, let's note that this is the valid PMF. If we add all these values, so these all add up to 1. And next, this PMF can be written in more compact form. For example, this probability value is 1 over 4 and this also is 1 over 4. So for example, we can write it in this form also. This is 1 over 4 when x is equal to 0 or when x is equal to 2, and this is 1 over 2 when x is equal to 1 and this is 0 otherwise. So another way to write the same PMF. Next, we need to find out the expected value first of all. So the expected value E of x, which is also denoted as mu x, is simply this summation. For all the values of x, there are only 3 possible values here. For all value of x in its range, we need to multiply each value of x with the corresponding probability at that value, right? And then we need to sum these values together, all these products together. So for this random variable, it can take on these values 0, 1 and 2, right? So expected value of x in this case is, for example, 0 multiplied by 1 over 4, then plus this is the summation, right? This then 1 multiplied by 1 over 2, then again 2 multiplied by 1 over 2 multiplied by the value 1 over 4. So expected value of x then is, this is 0, then this is 1 over 2, and this again is 2 over 4, which is again 1 over 2. So the expected value of x, or mu x, is basically 1. So this gives us the expected value of x. Now let's find the variance and the standard deviation. We know that the standard deviation is only a square root of a variance, right? So let's first find variance. Now we can find variance in many ways. The 2 ways are, for example, expected value, the variance of x, which is also denoted as this sigma x square, right? And this is equal to expected value of x minus mu x square, right? This is the expected value of this x minus mu x square. Or if we expand this, we can show that this is also equal to expected value, which is denoted as sigma x square also. This is equal to expected value of x square minus square of the expected value minus mu x square, right? So mu x is, note that is just the expected value of x. So the compact way to write this expected value of x. So let's find the variance both ways. First we will find the variance using this method, and then we will find the variance using the next method. And note that we already know the value of mu x now. The expected value of x, we already know it. It is 1. Right? So now we also know that the formula for the expected value of x is this. So the expected value of x minus mu x square will be, just we need to replace this x here with this term, right? X minus mu x square multiplied by px of x. So this will give us this expectation, which is the variance of x. So let's find the variance the first way, that is this method. Variance of x is equal to this also denoted as sigma x square, and this is equal to expected value of x minus mu x square. This is actually the definition of the variance of x for a random variable. So So this expectation, as I have told you, this can be equal to like this kind of formula. Let's write it down. This is equal to this summation for all elements of range of x. We need to multiply x minus mu x square. We just need to replace the x here with x minus mu x square and then multiplied with px of x. So multiplied by px of x, right? So we now use this formula to find the variance of x. So variance of x is equal to, so we know that the x can take on these three values 0, 1 and 2. So we say 0 minus, and mu of x is, we already found it, it is 1, right? So 0 minus 1, the first value of x, the 0 minus 1 squared multiplied by the corresponding probability, which is 1 over 4 at this point, 1 over 4 plus this, no, x is 1 minus mu x, mu is also 1, so 1 minus 1 square multiplied by the corresponding probability, which is 1 over 2, and then plus x2 minus 1, so 2 minus mu x, and this is 1 squared multiplied by the corresponding probability, which is 1 over 4. So variance of x is now equal to, this is 0 minus 1 is minus 1 squared is 1 into 1 over 4 is 1 over 4, and then this value is 0 multiplied by 1 over 2 is 0, and this is 2 minus 1, this is 1 squared into 1 over 4, this is 1 over 4, so this is 1 over 2, right? So we can say that the variance of x sigma x square is 1 over 2. So this is by using the first method. Now we can also use the second method. The variance of x sigma x square is equal to expected value of x square minus square of the expected value of x, right? So see the difference. This is the expected value of x square, and this is the square of the expected value of x, right? So we already know the expected value of x, this is 1. We just need to find this thing, the expected value of x square. Note that this is also known as the moment, second moment of x. So this is second moment of x around the origins, and this is the second moment of x around the mean, around the central moment, right? So we need to just find this value. We already know this. So expected value of x square, now we just need to replace this thing with x square, right? So this is equal to this summation for all the elements of this range of x, for all the values of possible values of x. We need to multiply x square with the corresponding probability. So expected value of x square is equal to, now again we have just three values of x, so x square, 0 square multiplied by 1 over 4, so 0 squared multiplied by 1 over 4 plus now 1 squared multiplied by 1 over 2, so 1 squared multiplied by 1 over 2 plus 2 squared multiplied by 1 over 4, 2 squared multiplied by 1 over 4. So expected value of x square, this is 0 obviously, and then this is 1 squared into 1 over 2 is just 1 over 2, right? And this is uh, 2 squared is 4 multiplied by 1 over 4, this is 1. So this is 1 whole 1 over 2 or 3 over 2. So this is the expected value of x square, but we are not finished yet. We still need to find the value of the variance of x. So the variance of x is given by this formula. So variance of x is equal to, we put in this value here, this is 3 over 2 minus this value, expected value of x, which is 1, and this is squared, and this will again come out to be 1. So variance of x is equal to 3 over 2 minus 2 over 2, which is 1, and this comes out to be again 1. So variance of x, or sigma x square, is just 1 over 2, as we already found. And now the third part, we still need to find the standard deviation. And before we find the standard deviation, note that the variance of x is defined by this expression here. So x minus mu x squared is always, as it is a square, this is always greater than or equal to 0, right? So it means that the variance of x is always greater than or equal to 0, right? So the standard deviation is just the square root of the variance. Standard deviation. Part C. So the standard deviation is usually denoted by just sigma x, right? And it is the square root of the variance. So in our case, the standard deviation is just the square root of the variance 1 over 2. So standard deviation is 1 over 2 square root. So this completes the solution to the given problem.